Hello, Forecaster here again, and we are back for episode 171. And in this episode, we are going to continue working on the tablet and the locomotive control. So, I'm recording this at the last minute. This episode you are watching was recorded yesterday, for me at least. And the reason for that is that I've been working on a tool because to do what I want, it's going to require a custom interface. And by that I mean I need to draw buttons on the tablet screen, and I need to detect when these buttons are being pressed. And to do that, you need to do a few things. So, I'm currently recording slightly differently. I have foregone the OpenGL recording mode where it targets Minecraft specifically, and I'm actually recording my desktop right now, which means I can do this. So right in here, in this program, which is on the tablet right now, we have a small program to make a graphical user interface. And what is happening is we take our GPU, which is a component we have, and the GPU is automatically bound to the screen. And we can tell the GPU to draw shapes on the screen at specific coordinates. So we have a method called fill, and this tells the GPU to fill the area from this coordinate to this coordinate, or at this starting position, x and y, and this size, width and height, with this character. And of course we have a space in there because we don't want an actual character, we just want the pixel to be empty. We also have the set background method, which allows us to set the background color, and you do this before you draw anything. And anything drawn after this method has been run will be this background color. There's also a set color or foreground, maybe, I don't remember exactly, that allows you to set the text color, essentially, which also affects this because that specifies what the characters will be, what color. So what this does is it sets the background color to red. It draws a square that is this size, which contains nothing, just blank spaces. Then it sets the background color back to black, which is the default, because otherwise when we exit the program and go back to the normal terminal, the background color is still going to be red, which will look pretty strange. So we set it back after we are done with drawing. So this will draw a small square in the top left corner of the screen. What we then do is start running a loop, which will run until this variable changes from true to false. We then use the event object, the event API, and use the pull method of that. So we're going to pull any event called touch, and the touch event is fired when you click on the screen, either on an in-world screen or in the interface with your mouse. Those are both the same event. Now you can fire arrows on the screens, and only Tier 2 and Tier 3 screens support touch events. But I'm not sure if firing an arrow also triggers the touch event or if it has its own. Um, so we want to pull the touch event. So when someone clicks the screen, we want the x and y coordinate of where they clicked, and I also collect the player who clicked, although I don't really use that. All the other stuff we can ignore. The first field is the event name, which is touch. The second field is the address of, I'm not actually sure. It might be the computer or the screen's ID or something. I don't know. It's the origin, or it's the computer's, perhaps. I'm not sure. And this is some number. I don't know what it is. So I'm ignoring it. We only really need the x and y anyway. So after that, the program will stop here until a touch event is fired. So it won't actually loop any until it gets an event, because this doesn't time out. Now, when it gets an event, it will put the x and y position that was clicked into these variables. Now, we want to check if our button we drew up here, our little square, was clicked or not, or if the click event was somewhere else. So we are using the x and the y to check if the click event happened within the area of the button or not. And if it did, if all of these are true, we will print hit and then end the program by setting run to false. If the click was outside, we will just print miss and then continue to run the program. Now, unfortunately, it prints these from the top left, since we cleared the terminal, that is the current cursor position, and then we'll go down. So we'll continue printing miss, and it will print over the button, as I discovered while testing this. But that is fine. Let's go back to Minecraft. We're going to start the tablet, and we are going to run the program. I'm going to show you what it does. Yeah, so this is the method you use essentially to create on-screen buttons. And then, of course, instead of printing hit or miss, so the program is called GUI or GUI, and here's our button. And if I click somewhere, it's going to print miss there. If I click here, so the coordinates, as you saw right there, are slightly wrong. I will have to adjust that. But if I click somewhere on the button, it'll say hit and the program ends. If I restart it and I click over here, the offset is not completely bonkers. It's just, I think it's one below the button that is included, even though it shouldn't be. If I click out here, it'll just keep saying miss because I'm completely missing the button. Now the button is still here, even though it's been drawn over. If I click here, it'll still say hit at the bottom here and end the program. So the way I got these values, like I said, I made a tool to assist me with this. And this line and all of this has actually been generated by this tool. Now the tool is still a work in progress. It's very bare bones still, but I have it here. So this is the Open Computers Interface Assistant, as I'm calling it. And as you can see, I've drawn an interface here. It doesn't support text yet, but I'm planning on adding that eventually. But what it allows you to do is, you can see I have a cursor here, and each of the pixels in this screen, which is currently the same resolution as the screen right here. At least I think so. Now I lost my train of thought. But yeah, this square should be the same, have the same amount of pixels as the in-game tablet screen. And each of the pixels highlight. So what I can do is I can select a position, and you can see the coordinates, the x and y coordinates of the first selection there. And then I can select a second position somewhere. And you can see the B selection got set as well. And if I click this button here, it's going to create a shape between those two positions. And you can select either corner first, it doesn't matter. And now you see that it doesn't highlight the individual pixels in this selection, because this is considered a shape, which is an object. If I click this shape, it will generate a fill method with the correct starting positions and the size, and it will assume the empty character, the white space, so it looks like this. And you can take this, and if we now go into here and replace, or actually let's add one to the program. We go in here and we run the GUI program. You can see that it drew a shape here, which is approximately in the same location as this. I'm hoping it's the exact same position, but I'm not entirely sure. Now you can see that it also generated some stuff down here, and this is the condition for testing if X and Y are within the button. Now, of course, these are slightly wrong. I still need to adjust that, and the issue comes from the fact that the language I'm using for this application starts positions and indexes at 0, while Lua, which is what Open Computers is using, of course, starts them at 1. So that creates some off by 1 errors here and there that needs to be adjusted for. And I have some of those in this condition string here. But what I can do then is take that string and go into the program here, and if I replace all of this with that, go out here, and now I can click that. Now if I rerun the program again, if I click up here, this button no longer works because I replaced the condition that was testing for this button. However, if I click on this thing, now it's going to say hit and end the program. And we should have the same issue if I click just underneath the button. It should still say hit. And it might also do the same thing if I click on this side. No? Oh, there it goes. Yeah. So it's including one below and one to the right of the button as well. Now, if we go back to the designer, I can delete this random shape that I made because I don't want that. And now you can see this other stuff. This is going to be my locomotive control interface. And you can see that we have a button for each of the modes. And you can also see that we have a button for each of the speeds, including reverse, which is going to be this red one down here. So I'm going to take one of these, go into my program, and we're going to delete these and insert this. Now this is going to be green, so we're going to want to have green there. And you can see that I'm also using the colors API to get the colors. And if you are doing this, you need to have this parameter set to true, because otherwise this method will expect this to be a hex value and not a number like this API outputs. So if you're using the color API, you need this to be true. Otherwise, you can, if you're using a hex value, which you can leave it out. But yeah, so we're going to want that to green. Now, all of these four are also green. So what I'm going to do is I'm going to insert those after each other, so I don't have to change the background color multiple times. I'm just going to save a little bit of power and some CPU power as well, because every time you run a method or function or anything, it's going to use a little bit of power. And the more complicated your program is, the more power it's going to use. Now we have a couple of red buttons. So I'm going to duplicate that, set the color to red, and then paste our two red boxes. And then we are going to need a yellow one. So we're going to take that and put it in here. And now, if I go back to the game and run the program, we have our interface. And it looks pretty much like the one in the designer, except the colors look a little different, of course. But that doesn't really matter. This is fine. So what we're going to want to do now is we're going to want to define the functions or the tests for the click events or touch events. So to do that, we're going to keep this thing right here. We're going to clear this out. I'm going to replace this. And this is going to be the run button. So I'm going to add a comment after this that says run mode, so I know what this is. And then in here, I would have a reference to a function that would be something like this. Set mode, and then something like this. Run. And then I could have a function defined at the start here that this would reference, that handles the broadcasting of the signal to the locomotive. So we're going to leave it like that for now. And then I'm going to do an else if, and now we're going to get the idle button. I'm just going to paste that there and then set type idle mode. And then I would have the set mode idle. And then have an else if, and then the shutdown button. And like I said before, I'm going to have the tool support text eventually, so you can label your buttons. But that is a low priority. This interface is really simple, kind of obvious. As long as you know what it's for, it's really obvious what the buttons do. So we're going to do that, and then end. Now, maybe I need a space there. I don't actually remember. What we can do is we can look at a different program. Should have the robot here somewhere. And let's do this. Have a look at the if Do I have any if-else statements? Oh, it's else. There's not a space. Good. Okay, that was correct. I was a little worried there. So that should do that. Now we're going to define a function here, the set mode, and then have a mode parameter. No, that's not how you do it. We need an end. And for now, we're just going to print the mode. And then we're going to go into here. Oh, need to have some water. Coding outside of the game can be a little hazardous if you forget to eat or drink inside of the game while you are occupied. But anyway, let's I'm going to want to click the currently invisible button here that I defined earlier. That is still being checked for. Now if I run the... Actually, if there is a click event, I'm going to want to set run to false to end the program, because otherwise getting out of it might be difficult. So let's run that. And now if I click... Alright, even if I click anywhere, the program is going to end. But it didn't print anything. Now if I click this button, it's going to print run. If I click this button, it'll print idle. And if I click this button, it'll print shutdown. So that is working. The offsets or the testing areas are still wrong, of course. So what we are going to want to do now, we're going to want to bind... Actually, we're going to do this. Local modem equals comp modem. Bind our modem, our wireless network card, to an object that we can use, and then we're going to want to do this. So if mode equals run, then modem broadcast, and I think if I recall correctly, it was port 2 for, let's see, should have the wiki for the mod up somewhere. There. Let's see, listen on port 2. Yes, port 2. And then I don't exactly recall the command. We go back in game. We open the Lua prompt. Can you... I think you can... Can you do sleep... No. OS sleep 1. Then a semicolon. There should be a way to execute multiple commands on the same line. Maybe you don't need the semicolon, actually. Sleep for 1, and then print hello. Alright, so that does work. So what I can do is... let's see. OS sleep. Yeah. OS sleep. And then component modem broadcast on port 2. Actually, we are going to want to open port 1 and then component modem broadcast. On port 2 we want to send doc, and was the T, and then we're going to want to do the event poll, and we're going to do put an equal sign before that so we print the result. And hopefully that is, oh, right. Probably have to do the equal sign in the beginning of the line if you want to do that, so we're going to do a print instead. And we might be too far away from the locomotive to get a reply, perhaps. Yeah, I think that might be the case. I'm going to go upstairs closer to the locomotive. Maybe I've done something wrong. That is a possibility. Let's try that again. Oh, wait. Duh, I did do something wrong. That should be that, and that should be that. And hopefully that yields something. No? Okay. Let's exit the prompt. We're going to go back here, and I'm going to create a new program. Actually, what am I doing? I'm being silly. I have the program I used here. The whistling program. We can just run that. What do you mean false? What's false? Print modem open. Alright, Is it... Does this not have the module anymore? Did something weird happen there? I'm going to make... Let's see. OC minecarts. I'm going to need a remote module analyzer. So I'm going to be back in a second. I just need to craft this stuff. Alright, I got the remote module analyzer, a name which I wouldn't have been able to remember if I hadn't had it in my heads-up display to the left there. I think... Ah, yes. Okay, so the wireless strength is not set to max. That is interesting. So I'm not sure why this isn't working. Should work. Shouldn't it? Why is it doing this? Did I break it? I might have broken it. Does it sense the command whistle? What if I send the command doc using this with the -T to get the commands? That's really weird. Now I think the event we want is called a modem message. Maybe. I don't actually remember. Modem broadcast port 2, we open port 1 for listening, and then sleep to not... Actually, let's remove that. This should be working. Unless there's something wrong with the mod, so that the module isn't responding, which would be weird. Because it is there. Not sure why it's not working. Not sure at all. So I can't really continue with the program unless I know that the module is working correctly. And unfortunately, we have reached the end of the episode. And I'm pretty sure that not sure why I said that. I was hoping that we would get this done in this episode, but I suppose we are going to have to come back and finish the program in the next one. And in the meantime, I'm going to try to figure out why the module is not responding. I might have to... I'm pretty sure you get the module back if you break the locomotive. Or is it actually permanently attached? Did I lose the module for doing that? It looks like I did. Well, that's a little annoying. I guess I'll have to make a new one then. Actually, let's do this. Let's spawn in a new one. We'll attach it to the locomotive, and we will poke it, make sure it's there, and then we're going to test this again. There we go. Now it's working. So it was actually the module that wasn't responding. If I break the locomotive now, do I get it back? I do. Okay, so I was supposed to get it back. So the module was simply missing, but the mod still thought it existed. Or the tool said it existed. Okay, that was weird. Alright, so I guess so the event is called modem message. So here we would have modem message, and then we don't need this sleep anymore because we don't have to wait because we won't catch any key or click events, touch events. So we are getting the list of commands. Now what I want to know is I want to know about the, let's see, mode command. I assume it takes a mode and then probably a number as the second parameter. So we're going to request the docs for that. Yeah. So mode takes a parameter that is a number. 0 is shutdown, 1 is idle, and 2 is run. So if we go back to this program, we are going to want to set this to mode, send that, and then if it's run, we're going to want 2, and then do else if mode equals idle, then modem broadcast on 2, mode 1, and else if mode equals shutdown, then modem broadcast on 2, mode 0, end. So what we should do now, all of this should be set up correctly. So I'm going to run the, not the gun program, I don't have such a program, the GUI program. Now the locomotive is set to shutdown. If I set it to any of the others, it's going to go into shutdown automatically because it doesn't have any fuel. If I put in fuel, now it doesn't have any water in it. I'm going to have to fix that, and I know we are over the normal quitting time, but I would prefer getting most of this done. So now it has water. Now I set it to idle or running, it's going to start heating up, and smoke will start coming out of it, which is going to indicate that this is working. So what I'm going to do is I'm going to look at this wall, so we can see the smokestack of the locomotive, and we're going to click the yellow button, and the locomotive starts. So it's now in idle, and it's heating up rapidly because of the firestone. Now if I run the program again, we click the shutdown, the locomotive should stop. No? Does that not work right? That's odd. Let's try the idle again. Now obviously the program is going to run continuously and not shut down after each button press. Okay, so that is working. So the shutdown is not working for some reason. But I might fiddle with that off camera, because I think now is a good time to end the episode, now that we've tested this. But yeah, like I said, I'm obviously going to want the program to, after a button press, loop around to, so when it goes here, it doesn't set run to false. Instead, what I probably would want is a quit button, probably in a corner, probably down here, that I can click that will end the program. But yeah, I'm also going to refine this, add some features like the ability to change the resolution, and probably save configurations, get them exported as text that you can save somewhere and then paste in to import them back again. Things like that. So, with that, I will see you in the next episode.